Welcome back in this series of lectures on soaps and detergents. In earlier lectures, we have seen various things related to soaps. Now we are to switch to the second part of the topic, which is detergents. So as per the scope assigned, we have seen introduction related to soaps, raw material, types of soaps, cleansing action, manufacturing of soaps by full boiled or hot process. Now in this video we are going to see the detergents, its general outline of raw materials, types of detergents. So the basic question is, what is detergent? A detergent is a surfactant, that is surface active material. A detergent is a surfactant or mixture of surfactants that has cleaning properties in dilute solution with water. So the general idea is it is a surface active material which works in place of soap. A detergent is similar to soap but have a general structure Rx, where R is the long hydrocarbon chain. Two things we have seen which differ in soaps and detergents. So soaps have general formula RCOOM and detergents have general formula RX. Okay. The other thing is that detergents are purely synthetic. Due to limitations of soaps, detergents were discovered. Because the raw material for soaps are having limitations, these are naturally available, and the raw material, its limitations and its tendency, especially soaps get precipitated in hard water. So due to such limitations, detergents were discovered. Coming to the same next part, like soaps, detergents are amphiphilic or amphipathic. Means in case of chemical structure of soaps, we have seen that there are two terminals. One terminal is hydrophilic, other terminal is hydrophobic. Similarly, detergents have both the terminals. One is hydrophobic, other is hydrophilic. So water soluble portion is there, water insoluble portion is there. Detergents are also known as syndates. So these questions will be asked in the form of MCQ or short answer type questions. So what are syndates? Syndates are synthetic detergents. These are purely synthetic. They are also known as soapless soaps. They work like soap but their chemical composition is different than soaps. The earliest developed synthetic detergents were short chain alkyl naphthalene sulfonates that were later found to be only somewhat good detergents, and so their properties were improved. So this is historical review. Those detergents are still used today as wetting agents. During 1920s and 30s, straight chain alcohols were sulfonated to produce straight chain detergents. So especially this period is period after First World War. Okay, so the alcohols were sulfonated to produce straight chain detergents. During the same time, long chain alkene and aryl sulfonates with benzene were developed as the aromatic nucleus. By the end of Second World War, alkyl aryl sulfonates swamped the detergent market over alcohol sulfates and later proved to be highly useful in shampoo industry. So these replacements were taking place. Those who are interested in soap and detergent industry in particular can go through these historical details. Otherwise, considering the examination structure, it is not essential to go through this historical review. Okay. Between 1950 and 1965, more than half of the detergents were based on the formula of propylene tetramer conjugated to benzene. It is called as PT benzene. But later they were blamed for a rise in eutrophication, excessive growth in lakes and streams as they contain phosphates, especially sodium triphosphate. By the year 1953, the sale of detergents in US has surpassed those of soaps. Actually, it was similar observation in entire world also. During that time, the detergents have all but replaced soap-based products that were used for laundering, dishwashing, household cleaning, etc. Alone or in combination with soaps, the use of detergents started in many of the bars and liquids used for the personal cleaning in different forms, in the form of liquids, in the form of solid powder, in the form of bars. These were used. In 1950s, liquid laundry, hand dishwashing and all-purpose cleaning products were developed. Automatic dishwasher powders, detergent with oxygen bleach, fabric softeners, rinse were developed. Rinse cycle was added. In 1960s, laundry powders with enzymes were introduced. Pre-wash soil and stain removers and enzyme pre-soaks were identified and introduced. In 1970s, fabric softeners, then multifunctional products and liquid hand soaps were manufactured and added in the market. In 1980s, automatic dishwasher liquids, detergents for cooler water washing and concentrated laundry products were manufactured. In 1990s, ultra, that is super concentrated powder and liquid detergents, automatic dishwasher gels, ultra fabric softeners, laundry and cleaning products, refills were introduced in the market. So this is a brief review what I say, and it is not essential for our examination, but those who are interested in soap and detergent industry can go through these details for their better understanding. Then the raw material related to types of detergents, because there are different types of detergents. Detergents are classified according to the electric charge they carry. So some detergents do not have any charge, they are called as non-ionic. Some carry a positive charge, some carry negative charge, some carry both the charges. So cationic, anionic, non-ionic are the types. So this is a list of different raw materials used for detergent industry, and the properties for relevant additives are also given. So you can go through these details, these slides, to get general idea regarding the raw material. So these are the raw materials used for detergents. Now coming to the classification. As I mentioned, detergents are classified into two major classes. One is non-ionic, other is ionic. Ionic are further classified into cationic, anionic and zetrionic or ampholytic. So you will be asked to explain the term or explain the classification. Okay. During classification you are supposed to explain the chemical nature and one or two examples of each type. Coming to non-ionic detergents. So non-ionic detergents are neutral detergents. They don't have any charge. As they don't have any charge, they contain uncharged hydrophilic group. Water soluble group is uncharged, but their solubility depends upon hydrogen bonding. This is the speciality. As the detergents are neutral, they don't have any charged terminal, but the solubility depends upon hydrogen bonding. They do not form salts with other ions. Okay, they have greater dirt carrying capacity. Prominently, these are ethylene oxide adducts. So we will see some examples. So ethylene oxide adducts or polyoxyethylene or ethoxylates are the different names. The general transformation is, so ethylene oxide undergoes reaction with alcohol-like structure to get the desired product. So fatty alcohol, alkyl phenols, fatty acids, fatty amides can be used for this purpose, which give this hydrocarbon portion and can be converted into corresponding ethylene oxide adduct. Efficiency of these molecules is higher with N is equal to 10 to 50. Number of carbons 10 to 50. These are excellent soil removers, scoring agents in textile industry. So these are some of the examples which are available in various textbook also. So stearic acid is there, then polyethyl glycol is there. These are condensation give the non-ionic detergent. Alkyl Rolamites is other class, other example of same class. So alkyl rolamites are the condensation products of fatty acid with alkyl rolamine. So what is alkyl rolamine? Alkyl rolamine is hydroxylamine. It has OH group, it has NH2 group and hydrocarbon portion. So when it undergoes condensation with fatty acid, that is RCOOH, undergoes condensation with NH2, CH2, CH2OH, it gives corresponding detergent. So the solubility is monitored by changing R length. You can vary the length of R portion and you can monitor or you can change the solubility. Used in shampoos and mixed with other detergents. So alkyl rolamides are prominently used in shampoos. So you can develop your own question bank while reading these slides or reading the reference material, and you can convert the information into various types of questions. So there are sugar surfactants. So one portion is having a sugar structure and it is again working like detergent, sugar surfactant. The second class is in case of ionic detergents, there are anionic, cationic and ampholytic. So anionic detergents have net negative electrical charge. The commercial anionic detergents are usually alkyl benzene sulfonates. There are two varieties. There are sulfates and there are sulfonates. We are going to see. Alkyl benzene is lipophilic and hydrophobic. So it can interact with fats or oils. The sulfonate is hydrophilic, so it can wash away soiling in water. Both linear and branched alkyl groups may be used, but the detergents made with linear alkyl groups are more likely to be biodegradable. So ionic detergents are sulfates and sulfonates. What is the difference? Sulfonates have SO3 minus group, sulfates have OSO3 minus group. So these groups are responsible for their solubility and cleaning action because the hydrocarbon parts are water insoluble and soluble in the dirt. Okay. So this is a general example. Dodecyl benzene is converted into corresponding sulfonyl derivative and ultimately into corresponding sodium salt, which is a detergent. Okay. This is a example of a branched sulfonate. Then this is a slide which indicates a soap molecule, a linear detergent and a branched detergent also. So all of these all together can be considered for differentiation also. Okay. Then as I mentioned, there are sulfates also. Sulfates contain OSO3 group. In this case, lauryl alcohol converted into corresponding sulfate and converted into corresponding salt is shown. This is a general transformation. Okay. So next class is cationic detergents. Cationic detergents have a net positive electrical charge. The chemical structure of cationic detergents are similar to those of anionic detergents, but the sulfonate group is replaced by quaternary ammonium group. What is the difference? The difference is that these detergents must have net positive electrical charge, and the positive charge can be generated by quaternization. So this is an example of cationic detergent where there is a positive charge over the structure. Then there is a last variety. In the beginning we have seen there are non-ionic detergents. In the second part we have seen there are ionic detergents. In ionic there are cationic and anionic. The last class is zetrionic or ampholytic. The name itself is indicative. It means these have both the charges. So zetrionic detergents have equal number of positive and negative charges in their structure. An example is CHAPS, which is 3 chloroamidopropyl dimethylamino 1-propane sulfonate. So the abbreviation is given. This molecule, like amino acid, have both the charges, positive as well as negative charges. So in your textbooks also various examples are given. You can go through these examples, and the assignment of this lecture will be: what are detergents, what is the write a note on raw materials for detergents, and how detergents are classified. So you can go through unit wise, and ultimately it will be convenient for you to learn regarding this topic, and you can prepare this topic for your industrial interactions. So with this I will stop here. Thank you.